I just stopped on the other device. I'm not sure why. I hope it recorded. Okay, so here's when I check these two rows. At this moment, I find my mistakes. Okay, from positive infinity.
They're supposed to be switched, right? The negative infinity and the positive infinity on the
x. See? That's exactly what I was going to say. How on earth will it be from positive infinity to 0 increasing? So that's exactly what I was saying. That's when I catch my mistakes. Thank you very much. Was it Amanda?
Oh, yeah.
Thank you. Thank you. Of course. It made no sense.
Before we move on to the next part, how did you know that it's negative between -2 and 6?
0, 0. 0, 0, negative 36.
Yeah, but those negatives that you have there are just for 0. It's not for everything between -2 and 6.
It is between -2 and 6. It's for every number I plug in between -2 and 6. Any number I will get negative. Guaranteed.
And okay, so how do you know that though? Just
0, 0, negative 36.
That,
You want to plug in 1? Let's plug in 1. 3 minus 12 minus 36, negative.
Right, but you didn't sit there and plug in a bunch of numbers, so I guess I'm asking why is just simply plugging in 0 there telling you all of that without checking it?
I did. 0, 0, negative 36. I plugged in 0.
Just one number.
I think
numbers, that means all of the things, that's just one number, I guess.
Professor, I think I understand her question.
Go ahead, Rita.
Okay, so Michelle, I think what you're asking about is why it's like negative all the way across from -2 to 6. And if you notice, the zeros for that point are at -2 and 6. Like there's a 0 there and a 0 there. So you can't have a change of signs in between unless there's another 0, if that makes sense.
Got it. So if whatever the sign of any number between those two zeros would be, it would be the same because it's the okay, that makes sense.
Also, if you want to graph this function, it's a quadratic function and it looks like this. It crosses at -2 and it crosses at 6. So it has a minimum, sorry. So it crosses at -2 and at 6.
Yeah. Got it.
So
okay.
it's negative between these 2 points and it's positive outside.
Okay, thank you.
Is that better? Yeah, and my camera, again, yeah, I have a hub of USB hub over there, and I think it's just very, very touchy. Okay, so is this clear? I mean, we've been using this for 2 or 3 weeks, so I'm not sure, was this not clear for so long? Why we get these symbols?
No, I understand where we get the symbols from. It's just sometimes you do things that you don't explain, and it doesn't always work or make sense to every problem. So I just was trying to get the why.
But I always encourage you to always stop me. You never ever allow me to move on if you have any question. Please, it will help me and you and everyone. Okay. So now I have to make sure that these two rows work well together. From -infinity to 0, the function is increased. Say it again.
Your professor, or your camera, sorry, your camera.
Yeah, I'm not really sure what's happening here. Why is it doing that? It should have no problem. Yeah, now it's disconnected completely. Okay, I think it's going to work now. Sorry about that. I'm not sure why is it doing this. Okay. Okay, thank you. So from negative infinity to 0, yes, it's increasing according to the sign of the derivative. From 0 to 40, yes, it's increasing. From 40 to 0, yes, it's decreasing. From 0 to negative, yes, it's decreasing. From negative to 0, yes, it's increasing. And to infinity, it's increasing. So everything matches correctly now. And now I have to look at the second derivative. And we get 6x minus 12. And when we set the second derivative equal to 0, why are we setting this derivative, second derivative equal to 0? What are we looking for? Someone who has not said anything yet. Noor, will you tell me why are we finding the second derivative and set it equal to 0?
No, I don't know.
Anyone else?
Are we finding the minimum and maximum?
Not with the second derivative.
This is to find the inflection points, right?
Very good. Very good. Thank you. 6x minus 12 equals 0. It means that x equals 2. Okay, very close. Very close. That almost my chart would have to be done again. Because they are too close and I need to explain. So this is a linear function. It comes from negative, goes to positive. So there is no discussion there. So the function does not hold water and the function holds water. But I also need to determine this number. So since I have the function in there, all I have to do is just plug in 2 now. I don't need that. I just need 2. No, I didn't mean that. I meant 2. Okay, so it's negative 88. Good, now we have absolutely everything. And let's establish what we have in the table. What type of point is negative 2 comma 40? Anyone else? Shvam, Alex?
It's an absolute maximum.
We don't know if it's an absolute, but we can definitely say that it's a relative max. Very good. What type of point is 2 comma negative 88?
Relative minimum point.
Very good. It's an inflection point. And what type of point is 6? That's why, because it's so squeezed in there. What can I say? What type of point is 6 comma negative 216?
Would that be the relative minimum?
Yes, it's a relative minimum because it goes down and up. Very good. Awesome. Great job. So now we're ready to graph. And obviously, it's not going to be a nice situation because of that negative 216. Did we graph this function before? Okay, so I have negative 3.71, 0. I have negative 2 comma 40. I'm going to break the the axis. So negative and top and bottom, negative 2 comma 40. So I'm going to say 10, 20, 30, 40. Okay. Okay. 0 comma 0. That's nice. 2 comma negative 88. I'm going to break it again. I have to. So I'm going to say 50, 100, and I have to get to negative 200. Okay. So this is 2 comma negative 88. So somewhere here. And 6 comma 0. And no, sorry. Negative 6 comma negative. I'm sorry, 6 comma negative 216. Sorry, right here. I will delete that. 6, 7, 8, 9, 10, right here. Okay. So let me make that the correction. And then we look at the table only. And we do what the table is telling us to do. Opening downward, increasing from negative infinity and crossing the x-axis at this point. Fine. continuing to the relative max at negative 240, still opening down. Increasing, still opening down to negative 2,40, where it starts opening down, continuing opening down but decreasing to the origin. Fine. Then it continues to open down but decreasing to negative 2,88. And I'm having a difficulty now because it should be looking like this, but you know what I mean. It's because of the scale. Okay. Where it has an inflection point, it changes concavity. From now on, it will always open up, and it will decrease to this point. So it decreases to this point, opening up. At this point, it was opening down, and now it's opening up. And then it crosses at this point, going to the positive infinity. So this is the graph of f of x. What was it? X cubed minus 6x squared minus 36x. So, yes, anything.
In the book, it gives a different way of doing these types of problems, which makes more sense to me than the table. If I do that on the exam, will I get points off?
No. If you find a different method that works for you and you show all the work, fine. And what is the method? What is it? How is it different?
Basically, you just don't draw the table, but you do everything in the same steps. So it says step 1 is find f of x. Then.
But how are you going to put them together? That's my question. If you don't have everything organized in a table, will you be able to put everything together?
If you sketch the graph, then you can see the difference.
You really cannot sketch the graph without organizing the information. And just to make sure, I accept any method. But if it's something copied from the graphing calculator, I cannot give any credit.
Oh, I see why that would... I see what you mean now. Okay.
Yeah. It's very good that you brought it up so that it's very clear for everyone. Anything copied from the graphing calculator brings 0 points. Sorry. You will not be able to put anything together, like you said, without looking at the graphing calculator. I have not looked at any calculator. I just determined all the information and put it in, organize it in this table.
The book just did test points. That was the difference. Rather than a table, it just did
that's fine. It will take much longer to do that, and it will be a hit and miss. I want to warn you about that. The table summarizes all the information, and you are looking in one spot before you graph. Anything copied from the calculator will not bring any points. I accept any method, but you have to show everything and why it's increasing and not decreasing, and why it's a maximum, and you have to put all this work on 4 pages. And 4 pages, you will not be able to organize it and graph it unless you look at the graphing calculator, which you can, but it will not bring points. That's all I'm saying.
Why are you saying 4 pages?
Because, look, I wrote 2 pages.
Oh, you're saying it will take 4 pages.
Yeah, I wrote 2 pages, and if my table would not fit, all these numbers, I would have had to write it again. It would be the 3rd page. And I can't look at 3 pages of work and put the graph together. I can't. But I can look right here where I have all the information summarized. It's increasing, it's opening down, it's opening up, it's increasing, it crosses the x-axis, it crosses the y-axis, it has max min, it has inflection points. Everything is written on this little piece. And because of that, I can graph it. But if I have everything spread on 3-4 pages, I won't be able to put the graph together. That's my point.